Hello and welcome to second lecture in 19th chapter of our comprehensive course on AI, ML and DS. Now in previous lecture we talked about measures of central tendency, mode, median and mean. Now we continue our discussion. The question is when to use which measure of central tendency. Now this is very important and nice discussion, and this website, as a statistical discussion you will find on many websites, but as far as I am concerned, I like two websites. I regard two websites very highly. One is this scribble.com and another is called Statology. Okay, so these two I am showing one by one. So this is that scribble.com, and in which I have opened the portion of my interest, that is statistics. Okay, otherwise if you just open scribble.com, you will find some this kind of thing, that plagiarism checker and all that. AI writing is also there. So it is, they are professional service providers, academic service providers, and they operate in many different things. Okay, so proofreading and all that things. If you are going for a course, then they will evaluate with your thesis, dissertation. If you are doing PhD, then they will evaluate. They will help you to design a better thesis and all that. Now that is fine, but we want, so here you will not find anywhere anything. So maybe in Learn, researching, writing, no, you will not find anything that way. So please remember that you have to go to this, and in that add statistics. So this is one side, okay, and similarly the other website is Statology. So that is this statology.org. Now this is also a very nice website, and you can see statistical is responsible to related to machine learning. Okay, so you should not think that you are learning something old-fashioned. It has become a fashion to use two fancy words for machine learning. Then, like say machine learning, then maybe artificial intelligence, and neural network and all that. Fine, they are there and they have their place, but fundamentals are fundamentals. So that is why I wanted to show this website, that if they have done basic statistics and then machine learning, so obviously that these two are related with each other. Okay, now here this is an org, so most of the things on this website you will find free. Okay, while this is a .com, so that means here also quite many free things are given, but there are many of the things are paid also. But at least what we want to discuss, that much is free. Okay, so now when to use which measure of central tendency. So if there is nominal data, I don't want to even open that, but you can write statistics and thereafter you can write nominal hyphen data. Then you will do a much detailed discussion. What is nominal data? There are certain data in which there is no inherent order. Okay, these are categorical variables, but there is no inherent order. For example, you are creating some population survey and you are writing ethnicity for your in a multipolar country like say United States. Now ethnicity can be say Asian, then maybe Caucasian, then maybe Chinese, or different African and all that. Now there is no order that Asians are higher and Caucasians are lower, or the other way around. Chinese are lowest or Chinese are the highest, Africans are lowest or Africans are highest. There is no order. They are just their terms to distinguish various parts of your data, that this data belongs to this ethnicity, this data belongs to this ethnicity, that's all. But you are not saying that this ethnicity is superior or it should be given when you encode it. At that time you should encode it by number 1, 2, 3, 4, and that 1, 2, you can encode by 1, 2, 3, 4, that is fine, that Asian is equal to 1, African is equal to 2, maybe Caucasian is equal to 3, and maybe Chinese is equal to 4, but that does not imply any order. That means they do not say that Asian is equal to 1 means Asian are the most superior race, or that ethnicity is the most superior, nothing like that. They are just meaningless numbers. Okay, so fine, just because computer understands number, you could not write anything other than number. Okay, otherwise you could have written A, B, C, D, 4 categories. Okay, political ideology. Now somebody can be socialist, somebody can be Marxist, somebody can be democratic, somebody may like dictatorships more. Even in democracy, for example, in US there are two main factions, Republicans and Democrats. In UK there are two factions, Liberals and Labour. Apart from, there are minor other factions also. So these are political ideology. Again, there is no concept of superiority or inferiority, unless you are staunch believer of one particular ideology, which is a bad thing for a data scientist, because a data scientist must remain impartial. He may in his individual capacity have any ideology, but while he is dealing with data, whatever data says that is final. He should not bring his ideology to, he should not allow his ideology to color the conclusions of the data analysis. Okay, so here political ideology, so that is maybe here also say Republican is shown by 1 and Democrats are shown by 0. So that is again, that does not imply any order. Okay, that is just randomly selected binary encoding, right? So if that kind of data is there, then you will choose this mode for measuring two samples. So that means if you have one data sample, maybe like this kind of graphs for Democrats, and or maybe this kind of graph, forget about the skew, and other data sample for Republican. Then if I want to compare the two, then I will not use mean or median, but I will use mode. What I'm saying is something like this. Okay, suppose this is the normal distribution, and for simplicity, I'm taking the normal distribution only. So suppose this is the normal distribution for the Democrats, and this is the normal distribution of all the data points of the population for Republicans, like that. So if I want to compare this blue with red, I could have compared their mean, I could have compared their median, but I would rather prefer to compare their mode. So what is the most frequently occurring number in this whole sample, and similarly what is the most frequently occurring number in this red sample for this political ideology, I will choose that. Okay, then ordinal. Now here there is some inherent order in the categorical variable. Okay, so that means, for example, you are a psychiatrist and you have multiple patients data who are suffering from anxiety disorder. Now if you have just that much data that anxiety is present or absent, not much useful. But suppose one psychiatrist was very meticulous and he is experienced for years, so he has a data of maybe 500 patients, and in which he has noted down the level of anxiety. That level of anxiety is 0. That means a patient who is not at all a patient of anxiety disorder. Then level of anxiety 1, moderate, slight anxiety. 2, slightly higher. 3, maybe higher. 4, say alarming, and 5, maybe immediately requiring attention, like that. So there is an inherent order that 0 is less than 5. So in that kind of data, where you find some order, then you should use either mode or median. Anyone can be used, but median is usually preferred. Okay. Income bracket. Now there also there is some order. Suppose you have decided to study the consumption behavior of a particular sample in your country, and for that you have divided your entire population, that is entire sample, into say bins according to the income. That this is the $10,000 per month to $20,000 per month income, high rich guys. Then these are $5,000 or 10 to 20 is a very big bracket. So maybe $10 to $15,000. Then maybe $8 to $10,000. That is another bin. Then $6 to $8,000. That is another bin. Then $4 to $6,000. That is another bin, and so on. Right. So what happens is, in that kind of case also, there is some inherent order. As I go from higher income to lower income, I should encode it in that manner so that it is apparent from the encoding that this is higher and this is lower. Okay. So there also mode or median can be used. Median is usually preferred, but it is depends upon the data. Now there is something called this interval and ratio. Now interval and ratio, the example are reaction time, test score in percentile. When you find in percentile, when you say that my score is I have scored 95 percentile. So that means what? 95 percentile means what? Your score is above the 95% of the students in your class, or that means you are only 5% of the students are above you. That is the meaning. And if someone has scored 100 percentile, so that means that that person is at the top of the class in the marks. 100% are below him, and no one is above him, right? But to calculate that percentile, you have to find the ratio of 2, or you have to find that is the definition. That is how percentile is calculated. You can try today, try to find out Google or ChatGPT or whatever, that how percentile is calculated. Okay. Then reaction time. Reaction time is usually measured for vehicles. When you apply the brake, suppose when you are driving and you see that there is some other car coming in, or some obstacle suddenly appears on the road, say a child runs in the road, on the road, or maybe in India, suppose a cow suddenly jumps on the road, and you immediately apply the brake, but still there is a fraction of second of time interval between you are seeing the obstacle and you are applying the brake. Okay, that time interval is called reaction time. Now that is an interval, so that is an interval type variable. Okay, and temperature, that is a kind of this test score is a ratio type variable, and in percentile, and the temperature is also an interval actually, because absolute zero temperature in Kelvin scale is decided at -273, and so it is actually, what is your, say, forget Kelvin scale but Celsius scale. So it is the scale which divides the 2 points, melting point of ice and the boiling point of water, in 100 equal parts. So melting point of ice is considered 0 and the boiling point of water is considered 100, and then it is divided into 100 equal intervals. So that is also an example. There you can use any type of measure of central tendency to compare two samples. Mode you can use, median you can use, or mean you can use. So very interesting discussion is given here. Please refer to that and spend some time, because the stronger you are in statistics, better you will be as a data scientist. And particularly those who are coming from technical background like BTech and computer scientists and all that, they usually have not learned all these things. So please learn these things, okay, in depth. Measure of dispersion, now second part. Okay, first part was measure of central tendency. Now measure of dispersion. So measure or variation. So they can be range, interquartile range, variance, standard deviation, and coefficient of variation. So what do they measure? So if I have 3 samples, all are normal distributions. One is this red colored sample, another is blue colored sample, and another is green colored sample. All are normal distributions. So that means for all, mean, median, and mode are same. And where they are, their peaks are also exactly coinciding. This is the green peak, this is the blue peak, and this is the red peak. So their peaks are also exactly coinciding. So then that means as far as any measure of central tendency is concerned, is there any difference between green, blue, and red? No, because mean of green is equal to mean of blue is equal to mean of red here. Median of green is equal to median of blue is equal to median of red again here. And similarly, mode of green is equal to mode of blue is equal to mode of red again here. Because I told you here that for normal distribution, mean, median, and mode, they are same. They coincide with each other. Okay. So then, but that means as far as any measure of central tendency is concerned, there is absolutely no difference between these three parameters, these three data distribution. But are three data distributions same? No. There is something still which separates them. What separates them? In common language, I can say that this is spread over less width and it is higher, more height. This blue one is spread over moderate width and it is having moderate height. And the green one, that is spread over the largest width and it is the minimum height. So that means apart from measures of central tendency, these I also need some measures of dispersion or measures of variability, that how much my data is varying. So for that we do this four: range and coefficient of range, mean or average deviation, variance, and standard deviation. Again, we had already done all of them in this fifth chapter. So let us quickly go through this. Range is the simplest thing, the highest value in the data minus the lowest value. So for example, here that was there and it was arranged in descending order. So 20 minus 2. So what is the range of this data? Then that is 18. So 18 is the range. Okay, fine. But for other things are not that simple. So mean deviation. So then mean deviation is what it is, observation minus x bar. Again, x bar is usually used for entire population. So I should read this as mu rather for sample, xi minus mu divided by number of observation. What is the meaning? For example, in that case only, here I can add another column, and that this column is my xi. Now that another column will be say xi minus mu. Now what is the mu? Then that will be this mean value or x bar, but for sample we should better use mu, that I have already told here. So 9.6. So that means these observation minus 9.6, these minus 9.6, these minus 9.6, and so on. So I will fill up this table. For that I am not spending the time of video recording, so I am pausing the recording and okay. So what this definition says is, take each observation xi and subtract the mean value from that, but take mode, that is modulus, absolute value. So that means positive will remain positive, and if this difference comes out to be negative, then that also should be treated as positive, converted to positive. Sum all those differences and divide by n. So here is my that data set. My difference was my mean was 9.6. So 20 minus 9.6, 10.4, 18 minus 9.6, 8.4, 15 minus 9.6, 5.4, and so on. Now here 8 minus 9.6, so negative values are coming. 7 minus 9.6, negative values are coming. So these are the values, but this says that, definition says that you have to take absolute difference between the observation and the mean value. So that means these you will treat as positive, these you will treat as positive, these also positive, these also positive, these also positive, and these also. And then add all this. So if you add all this column is xi minus mu column or xi minus x bar column, then sigma xi minus x bar, that will come out to be 52.2. And the definition says that you have to divide by number of observations. So that is 10 observations here. So that means 52.2 divided by 10. So what is the absolute variation? Then that is mean or average deviation. Then that is equal to the 5, that is here 5.22 for my this data set, or in general it is found by taking the positive difference between each observation and the sample mean and dividing by the total number of observations, summing those differences and then dividing by total number of observations. This is called mean absolute deviation actually. So here MD is written, but actually MAD is written. So MAD, of course it looks like that, but that is it is mean absolute deviation, just to remember. Otherwise it will give false idea if you don't convert negative to positive, then some positive values and some negative values will cancel each other. So it will give false idea that data does not have much deviation. Okay, so which data will have more deviation in this case? So the green data, its mean absolute deviation will be highest. The blue data, it will have mean absolute deviation less, and this red has minimal mean absolute deviation. That you can see its data points are close to the mean, or they are deviated less from the mean. This dotted vertical line, that is the mean. Here the data points are moderately away from mean, and for the green graph data points are far away from mean. So deviation from the mean is the highest for the green graph. Then variance. Now this variance and standard deviation we had already done in that fifth chapter. So this was that example which we had taken. So suppose these are 13 observations. So this is the observation number index only. These are the actual values of observation. These are heights of some 13 people in meter. So these are the values. I found first mu. So mu I got that the sum of all these observations divided by number of observations, and mu came out to be 1.666. So first I find xi minus mu, deviation. So that is this xi minus this mu for each observation. So 2.10 minus this, 2.05 minus this, 1.90 minus this, 1.75 minus this, and so on. And finally I got this 0.334, okay, is the last deviation. Now in this case also you can see that I got some positive, some negative, like that. So I have to, I'm here squaring it. So when you square, positive numbers will remain positive and negative numbers will remain negative. So this column gives xi minus mu. So this column will give xi minus mu whole square, right? Squared deviation, or that means 0.434 square, 0.384 square, 0.234 square, 0.00084 square, and so on. Or that is the squared deviation. And if you do the sum of these, then that will give sigma xi minus mu whole square. So the summation of this is all this column, that will be sigma, this third column, rightmost column, that will be this part, sigma xi minus mu whole square. And then you divide by n minus 1. Okay, so that means this whole divided by n minus 1. That gives you variance. Now if you are finding for sample, then you divide by n minus 1. If you finding for population, then you divide by n. That is the total number of observations. But remember, for population, it is not possible to do in most of the cases, because I told that example of Amazon, etc., or Walmart, etc. So population will be 2 million customers data. So you cannot calculate for population. You can always calculate for sample only. And entire statistic is nothing but the art of estimating various metrics related with population by calculating same metrics related with the sample. So that means the mean of population is x bar. I cannot find it because the population is very large. So I have to find mean of sample, and I have to find it under some such assumption and such conditions, so that these two are equal, or that means sample mean should give a fair estimate of the population mean, reasonably good estimate. Similarly, sample median, if you find, that should give fair estimate of population median, and similarly sample variance, if you find, then it should give the fair estimate of population variance. So this is itself the variance. That means sigma xi minus mu whole square divided by n minus 1. That is variance, and more the variance, more the graph will be spread out. So here again, if you see, the red graph has minimal variance, blue graph has moderate variance, and green graph has a higher variance. Okay, and then standard deviation is nothing but the square root of variance. So that also we saw in that chapter, that if you find square root of variance, that term is called standard deviation. So sample standard deviation is square root of variance. Okay, so that is again just a revision. Okay, so that is standard deviation is square root of variance. And this standard deviation is a very important parameter, because one, its the unit will be same as the unit of the quantity being measured. See here, this height is in meter, but this variance, when I find xi minus mu also is in meter, but I am doing xi minus mu whole square. So the unit of here, this each term will be meter square, and when I do their sum, that also will be meter square. So this whole term is in meter square, and this is just a number. So what will be the unit of variance? It is meter square. But when I take the square root and find the standard deviation, again the answer comes out to be in meter. So standard deviation is considered as its name itself is standard. It is the standard measure of the deviation in my data. So if I want to express that this red data deviates the least from the mean, blue data deviates the moderately from the mean, and green data deviates the most from the mean, then I should say that this red has minimum standard deviation, this has moderate value of standard deviation, and green has the highest standard deviation. Okay, so that is what it is. So range is maximum minus minimum value. Mean absolute deviation is each observation minus the sample mean in modulus divided by number of observation. Variance is each observation minus the sample mean whole square. Summation, sum of all those terms divided by number of observation n minus 1. Because as I said, we always calculate for sample. Okay. Then standard deviation for this sample is sigma xi minus x bar whole square divided by n minus 1 in the square root. So variance, its square root is standard deviation. Variance is most stable measure, and variance is used in inferential statistics. Range, if you see about each some discussion is done, but I have preferred to do the discussion very simply by providing a good diagram for each only. So if you see, this is the observation 0 to 14, it varies. So the range is 14 minus 0, or maybe say 1 2, because this data point is at 1. So 14 minus 1, so 13. While here also these are the two different data distributions. Here 7, 8, 9, for each value there is only one data point. While here for 7 there is a data point, 8, 9 does not have any data point, 10, 11 has a data point, and 12 has 3 data points, right? So in this case, this 12 minus 7, that is equal to 5. Okay, that is the range. While here it is 12 minus 7 is the range, but Are these two data distributions equal? Ranges are equal, but are these two data distributions equal? Then no. So that means range has this disadvantage that it does not give idea about the distribution of data, how the data is distributed. Okay, that is first disadvantage. Just like here I said that all three graphs have same median, same mode, and same mean. So that means the measures of central tendency are same, but the graphs are not same. So we need something more apart from measures of central tendency, and therefore we defined these measures of dispersion. Okay, so among that, this range alone is not enough. That much is clear, because range ignores the way in which data is distributed. Also, another drawback of range is that it is sensitive to the outliers. For example, if these are observations and these are also suppose same number of observation, everything is same between the two data sets except the last observation. Here the last observation is 5 and here the last observation is 120, and as soon as you see this, the range of first data set will become 4, bigger minus smaller, but range of this data set will become 119. So that is nearly 30 times more. But does it give the real picture about the two data set? Are the two data set that different? Is one data set 30 times more different than the other one? No. So we defined another parameter that is called coefficient of range. And what is coefficient of range? There range is defined as larger minus smaller. So then we divide it by larger plus smaller. So then larger minus smaller divided by larger plus smaller. And that will solve the issue to some extent. For example, here 5 minus 1, 4 divided by 5 plus 1, 6. So 4 by 6, that is 2 by 3, that is 0.6666. And here 120 minus 1, 119 divided by 120 plus 1. So that is 121. So that is 119 divided by 121. Okay. So if I find it 119 minus 121, then it comes out to be around 0.98. So this is 0.66 and this is 0.98. But now at least you can say that this is not 30 times different than this. So range does not give very clear idea. Coefficient of range, that is range divided by the sum of larger and smaller values, that gives more clear idea. Okay. Now interquartile range. Now that and this we will take in next lecture, because otherwise this would become very long. But even this is just a revision. You can see here we have done interquartile range and all these things, sir, perhaps somewhere in the box plot and percentile and quartile and everything we had done. So not in this chapter but in some other chapter. Okay, so we will take this in next lecture. Thank you and see you in third lecture.